Hello friends, welcome to the channel Base of Btech. So let us start a new topic from mechanics, which is moment of inertia. That is, if we need to rotate a body about an axis, of course that body will offer some resistance for its motion, and that resistance is measured using the term moment of inertia. Okay, and before you start understanding moment of inertia in detail, let us study what is centeroid of an object. Centeroid is the point where the whole area of the body is assumed to be concentrated. Okay, and also we can define that the centeroid is the point where the whole weight of the body is acting on. Okay, centroid we can call in another way, it is a center of gravity also. Okay, so today's class we are going to discuss centeroid of various shapes. See, I am going to draw a random figure, and obviously there will be a point where the whole body acts, which we call it as centroid. So centroid will be some point over here or anything, and this point will be represented using x coordinate and y coordinate. So for centeroid, the x coordinate I write it as x bar and y coordinate is y bar. Okay, and we have to find the x bar and y bar value. And the general expression for x bar, the x coordinate of centeroid, is integral x dA divided by integral dA. That is, I will be drawing a small strip, a small vertical strip. Okay, before that I need to place this particular figure in the xy coordinate system, also in the first quadrant, and after that I am going to draw a small thin strip which is of distance x from the y axis. Okay, that x multiplied with a small area or the area of the small strip, and that product is integrated divided by the total area will give you x bar. And similarly y bar is integral y dA divided by integral dA, which means I need to draw a horizontal strip somewhere, a horizontal strip, okay, and which is of distance y distance from your x axis, and the area is dA. Okay, here also the area is dA, and here too the area is dA. So the y multiplied with dA, and if you take the integration divided by the total area of the object will give you y bar. So for various shapes like rectangle or square or triangle, circle, etc., you will be having a particular defined centeroid point. So for time being I am not going to explain or I am not going to derive the centeroid. I will be listing out the centeroid of every shapes, every frequently asked shapes in a table manner, and we will proceed the class. So firstly let us take a figure which is of this kind, an irregular shape, okay, but still it is having one vertical symmetry. And if you need to find the centroid of this figure, you have to paste it in your first quadrant xy plane. Okay, so for whichever figure you need to find the centeroid, please paste it in the first quadrant xy plane. And if you feel like the figure is having a vertical symmetry, then you can be make sure that your x bar is lying on that vertical symmetry. Your x bar will be always on the vertical symmetry, but we do not know where the position of y bar is. It depends on the whole area of the body. Okay, so anyway in this vertical line you will have your x bar, but your y bar depends somewhere according to its area. Okay, so your x bar lies on the vertical symmetry, and for y bar it is simply integral y dA by integral dA. Okay, now the figure if somewhat like this, and if the figure is having a horizontal symmetry, again please paste the same in your xy plane, first quadrant xy plane, and you can be very sure that your y bar lies on this particular line. That is, your y bar will be always lying, it lies on the horizontal symmetry. If the figure is having a horizontal symmetry, then your y bar lies on it, and x bar, again you do not know the position of x bar, it depends on the area of the figure. So it is like integral x dA by integral d. Okay. Next is I have drawn many basic shapes, that is rectangles arranged in two manners and square and right triangles arranged in these many manners. So, we are going to find out the centroid expression for each figure. Okay. For the rectangle, it is like, you can see that rectangle is having of course a horizontal symmetry, also a vertical symmetry. Okay. If the rectangle is of length L and breadth B, then you can make sure that this point will be your centeroid, which is having L by 2 and B by 2. Since this is B, half will be B by 2. So, your point or the centroid point is L by 2 and B by 2, L by 2 comma B by 2. Similarly, here also if it is arranged, if this is your B value and this is your L value, and the rectangle is of course having a horizontal symmetry, so it is again B by 2 comma L by 2. X coordinate will be half of B and Y coordinate will be half of L. And square, of course every side will be 1 and only A. Okay, so the centroid will be just middle of the square, which is A by 2 comma A by 2. Okay. Now for right triangle, the case is somewhat different, that is base is B. This is your B and your height of the right triangle is H. Now this is not having any symmetry, horizontal symmetry or vertical symmetry, it is not having any. So it is the point somewhat like here with your x coordinate as B by 3 and y coordinate as H by 3. See, this point is B by 3, whole is B and we have to take the x coordinate as B by 3 and this height is your H by 3, and please understand that we are measuring that B by 3 and H by 3 from your right angle where it is marked, right angle point. Here also the formula stays the same, but when I explain it with respect to the xy coordinate in the first quadrant, it gets somewhat different. Just see, here the right angle is over here, isn't it? So centeroid is measured from this point, that is measured from this right angle, that is your H by 3 will be somewhat here, I mean the y coordinate will be somewhat here in this line, and you have to measure the x coordinate from the point where right angle is measured, that is B by 3 is measured from the right angle point. So it is starting from the right and measured through B by 3 and we get the axis. So this is your centroid for right angle placed in this way. So but again, if I am going to mark the coordinate, you have to do like this, completely it is B, isn't it? Let me make it clear. This complete figure is B length and this particular length is B by 3. So when you put it in the coordinate, it becomes like B minus B by 3, isn't it? B minus B by 3 is your x coordinate and y coordinate is simply H by 3. Okay. And here, take, if you have a right angle figure, first thing is you have to search for the right angle mark, this over here. So measure your H by 3 from this point, this is your H by 3 and it comes till here, and this is your B by 3, it is coming till here. So this would be your point, but how to write in coordinate? See, the whole length is H and we are taking H by 3 from the top portion. So the coordinate for the y coordinate will be H minus H by 3 and for the coordinate in the x coordinate will be B minus B by 3. In this figure also you can see the marking, right angle marking was over here. So take your B by 3 starting from your right angle point and this is your B by 3, and starting from right angle point this is your H by 3. So it is coming like here, isn't it? So your x coordinate will be simply B by 3 and y coordinate you have to minus the H by 3 from the whole side H. So it is like H minus H by 3. Okay. Next is isosceles triangle with base B and height H. Here the case is different because the figure is having a vertical symmetry and we know that x bar lies on the vertical symmetry. So this point is just half of B. So x bar is simply B by 2 and y bar you have to again take the right angle point. But since this is a isosceles triangle, if I cut it into two, you get a right angle over here, isn't it? So your y bar can be measured from this point where you can see your right angle. So it is simply like the previous h by 3 measured from the right angle point, and you will get somewhat here. Your y bar will be existing somewhat here. Again it is h by 3. And the isosceles triangle is reverted and kept. Then again the same. Here you have the vertical symmetry and this is your b, right? So your x bar will be again b by 2, and y bar again you have to check where the right angle is. Here is your right angle, measure from that point your h by 3. So it is somewhat here, but coordinate at this point is completely you have it as h. So this point is complete h minus h by 3. So this point is y bar is equal to h minus h by 3. Okay, and here in this case, this is also an isosceles triangle, but it is having a horizontal symmetry. So your y bar is existing in this point, and this length is base, isn't it? So it is b value. So your y bar is existing. See, I have said you that if you are having a horizontal symmetry, your y bar exists on that point, isn't it? So your y bar is actually b by 2, and your x bar is, see, again check out for your right angle point, and from that point you just measure your h by 3, isn't it? The whole length is h, isn't it? So taken h by 3 from the right angle side, you get x bar is equal to h by 3. Okay, and lastly, isosceles triangle arranged in this way. You have again a horizontal symmetry here, and this complete length is h and this complete length is b, and the horizontal symmetry is lying through b by 2. So your y bar will be b by 2, and your x bar will be, you have to check out for the right angle position and just mark your h by 3, and putting into the coordinates you get like h minus h by 3, isn't it? Complete is h, reducing h by 3 from here you get like h minus h by 3. Okay, now it is sectors arranged in these manners, and actually I have drawn quadrant here. You can see it is sector is of 90 degree included, angle is 90 degree here, and this case you are having your x bar like 4r by 3 pi, where r is your radius. See, this is your r and this is your r. So your x bar is 4r by 3 pi, and y bar is also 4r by 3 pi. Okay, so that's the way, and the quadrant is flipped horizontally and kept. So again in this position also, please mark your 4r by 3 pi from the right angle point. So it is here, isn't it? So measure your 4r by 3 pi from this side, and putting into the coordinates completely it is r. And how can we get this point? It is like x bar is equal to complete r minus 4r by 3 pi, and y bar is again measure from the right angle position, it is simply 4r by 3 pi. Okay, so I have marked the x bar y bar for the rest of the two figures also. Now let's move on to semicircle with radius r. Here also you can see the symmetry coming here, isn't it? Here you have a vertical symmetry, and this radius is r, so this completely it is 2r. Okay, so the vertical symmetry is lying on rth position, isn't it? This is your r value. So your x bar will be lying on vertical symmetry, which is r, and y bar again you have to search for the right angle point, it is over here, and measure your r by 3 starting from your right angle. I mean 4r by 3 pi. Okay, so y bar is equal to simply 4r by 3 pi. Got it? Now the semicircle is flipped vertically, and again you can see the vertical symmetry coming up, and your x bar is lying on this point, which is r away from origin. So x bar is simply r, and y bar is again, you have to check out for the right angle position. It is over here, and measure your 4r by 3 pi starting from your right angle, and complete, this is your 4r by 3 pi, and completely it is r. So coordinate wise y bar is like r minus 4r by 3 pi. Again here the symmetrical line is different. It is having a horizontal symmetry, so y bar is lying on this particular symmetrical line, and this symmetrical line is r away from origin. So y bar is at r, and what about x bar? X bar is, again search for the right angle position, mark your 4r by 3 pi from that particular value, point, and your x bar is 4r by 3 pi. Similarly, here y bar equal to r and x bar is equal to, see, here is your right angle. So totally it is r, and you have to take your 4r by 3 pi from your right angle. So it is r minus 4r by 3 pi. Okay. Lastly, in circle with radius r, you can see both symmetrical lines. That is, there is a vertical symmetrical line, also horizontal symmetry. So your x bar and y bar will be, x bar will be on this line, and y bar will be on horizontal line. So it is just r comma r, or x bar is equal to r and y bar equal to r. The center of the circle is the centeroid for your circle. Okay, so that's all for today's class. If you like the video, please like, share and subscribe it. Till we meet in the next class, this is Meenu signing off. Thank you and take care.